The natural logarithmic function. The inverse function of f of x equals e to the x is a natural logarithmic function and is denoted by the special symbol lnx, read as the natural log of x, or, as I read it, ln of x. So the natural logarithmic function, the function f of x equals log base e of x, and we just write it as ln of x when x is greater than 0. So that is the natural logarithmic function. The equations y equals ln of x and y equals e to the y are equivalent. Note that the natural logarithm ln of x is written without a base. The base is understood to be e. So let's evaluate the natural logarithmic function. So we're just using a calculator to evaluate the function f of x equals ln of x at each value of x. So we're just plugging it in. So natural log of 2. So on your calculator, you will press the ln button, and then 2, and then enter, and then so you will get 0.693147, and then 2. 1, 2, 3, 4, 5, 6, 7. So maybe 7 decimal places. So go ahead and try these next 3, and when you come back, I'll have the answer for you. Okay, if you tried this out, you would have gotten negative 1.20397 for letter B. Letter C, it's an error. You get a complex number because you can't have a negative value, so same as the log. And letter D, we get 0.88137. Let's take a look at properties of logarithms. So natural log of 1 equals 0 because e to the 0 equals 1. E equals 1 because e to the first power is e. Number 3, natural log of e to the x equals x, and e to the natural log of x equals x. It's inverse properties. Then number 4, if natural log of x equals natural log of y, then x equals y. So let's use those properties of natural log to simplify each expression. We have natural log of 1 over e. So what we're going to write is, let's rewrite that as natural log of e to the minus 1. And then, so know this, remember this is the property up here, number 3, that cancels out. So our answer is just negative 1. Letter B, e natural log of 5, e raised to the natural log of 5. So that's the inverse property. We know the answer is just 5. Number 3, we have natural log of 1 over 3. Natural log of 1, going back, is 0. So this is 0 over 3, so the answer is 0. Okay, that's property number 1. Number 2, letter D, we have 2 natural log of e, so natural log of e cancels, so the answer is 2. So go ahead and try these 3 down here. Pause the video and try them out. So if you try this out, letter A is a third. Letter B, that's 5 times 0, natural log of 1 is 0. And then letter C is 3/4. And then letter D, it's just 7. So let's look at finding the domains of logarithmic functions, and for now we're focusing on the natural log. So for letter A, we have f of x equals natural log of x minus 2. So we know it's shifted to the right 2, and so we know our domain, therefore, is going to be 2 to infinity, right? So it's not going to hit that asymptote. We just shifted the vertical asymptote to the right 2, and so it's 2 to infinity. Letter B, we look at our domain, and so it needs to be greater than or equal to 0, right? So in order for that to be greater than or equal to 0, the x value has to be 2 or anything less than 2. So our domain in this case is negative infinity to 2. Letter C, we have natural log of x raised to the square. And so in this case, we could have everything except for what? We cannot have 0. So our domain in this case is from negative infinity to 0, union 0 to infinity. So try this last example. Find the domain of f of x equals natural log of x plus 3. Okay, if you tried this out, you would know that the domain has to be from negative 3 to infinity. Not included because it's not going to hit that vertical asymptote. Number 11. So this is an application problem. Students participate in a psychology experiment, attended several lectures on the subject, and took an exam. Every month for a year after the exam, the students took a retest to see how much of the material they remembered. The average scores for the group are given by the human memory model. f of t equals 75 minus 6, natural log of t plus 1, and t has to be between 0 and 12, where t is the time in months. So what was the average score of the original exam? T is 0, so you make this 0, and you're going to do 75 minus 6, natural log of 1. So plug that in. And you know that natural log of 1 is just 1, so the answer is 75. Letter B, what was the average score at the end of 2 months? So if you plug it into your calculator, you can kind of retype this in, or you can just change that value. So when you plug that in, you will get approximately 68.41%. Then the average score at the end of t equals 6 months, so 75 minus 6, natural log of 6 plus 1, you will get approximately 63.32. Okay, so just practice plugging it into the calculator. So try this, the last example here, in example 11, find the average score now at 1 month, 9 months, and then the last one is C at t equals 12 months. So if you tried it out, if you plugged in t equals 1, you'd get approximately 7.84. At time 9, at 9 months, that would be about 61.18%. And at a year, 12 months, that would be approximately 59.61%. So I hope this helps. Thanks for watching.